Hello Gators, welcome back. Today we're going to make lists of all the possible outcomes for a simple event, make a tree diagram to generate all the possible outcomes and combinations for a compound event, and organize the combinations from a tree diagram into a list. So let's go ahead and get started. Let's first start with our sample space notes. What is a sample space? Well, the sample space describes all the possible outcomes of an event. The sample space can be displayed with lists, tables, or tree diagrams to determine the probability of simple or compound events. So, for example, the New England Patriots and the Dallas Cowboys are playing. What are the possible outcomes? Well, the Patriots win, which means the Cowboys lose, or the Cowboys win, which means the Patriots lose. And then we have a number cube is rolled. What are the possible outcomes? Well, let's say the number cube is labeled 1 through 6. Well, then the possible outcomes are 1 through 6. If the number cube is a 1 through 4 cube, then it's going to be 1 through 4 as your possible outcomes. So let's look at using lists for simple events. So question 1 says, for breakfast, Jamie can choose from a muffin, cereal or eggs, and coffee, orange juice, or milk. What are the possible outcomes, and how many total outcomes are possible? Well, let's say she chooses something to eat and something to drink. Well, then these are her possible outcomes. She could choose cereal and coffee, cereal and orange juice, or cereal and milk. Or she can choose eggs and coffee, eggs and orange juice, or eggs and milk. Or muffins and coffee, muffin and orange juice, and muffin and milk. So she has 3 drink options. Multiplied by 3 food options gives her 9 possible outcomes. If you count each one that we labeled out, it also equals 9. Another example is, at registration, a student can select from Spanish or German class in either art, music, or theater. What are the possible outcomes? How many total outcomes are possible? Well, they can either choose Spanish or German for language, and then they have an elective option for art, music, or theater. So these are the possible outcomes: Spanish and art, Spanish and music, Spanish and theater, German and art, German and music, and German and theater. So we have 2 language options multiplied by 3 elective options gives us 6 possible outcomes. Again, if you count each one of these, you would get Spanish and art, which is 1, Spanish and music 2, Spanish and theater 3, German and art 4, German and music 5, German and theater 6. So that's 6 outcomes in total. Last example for tree diagrams for simple. A fair coin is tossed 3 times. What are the possible outcomes? How many total outcomes are possible? Well, we know a fair coin is either heads or tails. Let's say on the first roll, we either get heads or tails. Those are our options. On the second roll, let's say we had heads, so that means we can choose heads or tails. If we roll the tails on the first option, like here, we can either get heads or tails. And so on and so forth, the roll 3. So what are all our possible outcomes? Well, you can have heads, 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 which is here. You can have heads, heads, tails. You can have heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 head, or tails, tails, tails. So how many total? I made a list off to the right of all of our outcomes, and it was 8 in total. So now let's look at using lists for compound events. So it says Amanda will roll a number cube with sides labeled 1 through 6 and flip a coin. So she's doing 2 things. That's what makes it a compound event. If Amanda rolls the number cube once and flips the coin once, then what are the possible outcomes in which the number cube lands on an odd number? So with 1 through 6, the only options you have for the numbers is 1, 3, and 5. Why is that? Well, because we can only roll an odd number. So we can choose 1 and heads. She spins a 1, rolls a heads. She can spin a 1 and roll tails. She can spin a 3 and roll heads. She can flip on heads. She can spin on 3 and then, or roll on 3 and flip on tails, roll on 5 and flip on heads, or roll on 5 and flip on tails. So she has 6 total outcomes for this event. So how do we use tree diagrams for compound events? Well, we have a clothing line has shirts in red, blue, or white, and pants in gray or khaki. A complete outfit consists of one shirt and one pair of pants. And then the question is, how many different combinations can be made with the clothing line, and how would adding a green shirt to the clothing line change the tree diagram above? How would that change the number of possible outcomes? And we need to justify that answer. So first I made a tree diagram. I said, well, we can choose red, blue, and white, or white. And then we can either choose gray or khaki pants. So how many different combinations is that? Well, we have 3 shirt options and 2 pants options. We multiply those two, we get 6 possible outcomes. If you listed the possible outcomes out, well, you can have red and gray pants, red shirt and khaki pants, blue shirt and gray pants, blue shirt and khaki pants, or white shirt and gray pants, and white shirt and khaki pants. So that is 6 total outcomes that we could choose from. So that would be 3 shirts times 2 pants is 6 total outcomes. So how would adding a green shirt to the clothing line change the tree diagram? Well, what it would do is a green shirt would add more possibilities. A 4th branch would need to be added. So we would have a green up here at the top. And then we have gray and khaki at the bottom added. So it would actually turn into now 8 outcomes, because we would have 4 shirts options times 2 pants options equals 8 total outcomes. All right, so today you have homework. It is on Canvas. It is going to be due November 12th, which is tomorrow. It's 6 questions, so make sure you get it done. If you have any further questions, be sure to reach out to your teacher through Canvas inbox. Have a good day, and I'll see you in the next one.